Good afternoon, everyone. How are you today? Are you good? Okay. Sorry,นะครับ on Monday for short notice because I was so sick. Then I couldn't just conduct any class on Monday. Then I had to just I was in the bed all the time because it was so sick on Monday. But now I'm better นะครับ All right. Okay. นะครับ so today we are talking about like the module 4 นะครับ that we had on the last class นะครับ including just like the examination นะครับ the midterm exam as well as the makeup class that we are going to have as well. Okay. All right. So on the last class we talk about the data flow diagram นะครับ I told you that for data flow diagram it will be our I will run the workshop for you guys as well. Then I just like plan the workshop for you already that I'll talk about it later on นะครับ Now let's see the content inside our module number 4 นะครับ for the content that we had on the last class นะครับ for the short recap first นะครับ Maybe you forgot it already because it's around a week ago นะครับ that we talk about this one. Now let's see ครับ On the last class we talked about data flow diagrams นะครับ Let me have the recap for what we studied นะครับ Whenever we had to do the requirement gathering นะครับ or information gathering from your users, you have to do the modeling in order to transform นะครับ the requirements into just like the understandable form that everyone can understand in both business and also the technical ones. So in this one ครับ on the last class we talk about this module นะครับ that is really important นะครับ in this one let me just like show you for the first part นะครับ this one when we talk about the data flow diagrams is the the diagram to show how data move from one point to another point in the information system. But anyway นะครับ it doesn't show the logic of the programs. It just like show the details of just like how the data flow from one point to another point. But in details for the logic of the programs, we use like other documents to help clarifying the logic นะครับ Okay, so set of data flow diagrams นะครับ we have two kind of data flow diagrams. One is the logical diagram นะครับ the other one is physical data flow diagrams. For the logical data flow diagrams, it's just like it's a model to show what the system does นะครับ While the physical diagrams tell us about the related database, related network นะครับ that we have to use with that system. Okay. Most of the time in this class, we try to just like mention about the logical data flow diagram so that we can just like continue on the next part in the design part นะครับ So in this one, when we talk about the data flow diagram นะครับ we have 4 different major symbols that we have to use. You pick one of this scheme นะครับ don't mix them up นะครับ because if you mix them นะครับ other people will be confused. So that means if you use gain and Sarsen นะครับ all of the symbol that you have to use will be in this standard นะครับ in this scheme. For process it must be in the rounded corner rectangle นะครับ For the arrow it means the data flow. For one open-ended rectangle นะครับ with the small vertical line here it's the data store. While the square นะครับ with the shade this is the external entity นะครับ But if you decide to use Jordan นะครับ you use like this right group of symbols. Circle means process นะครับ arrow means that data flow the same นะครับ and two open-ended rectangles นะครับ here means the data store and the plane to the square, this is external entity นะครับ and after that we talk about the next one นะครับ when we talk about the symbol นะครับ of like those symbols that we saw on the previous slide process นะครับ process symbol นะครับ is the symbol that used to receive input นะครับ data and process the output or produce output. That means when you draw the process, you must have input and output of the process. If you have a process that receives just input but it doesn't produce output, you are wrong นะครับ you have to rethink about it. If you have just the process that produce the output but it doesn't have the input, how do you know that this process will create the output? What kind of data that this process need to use in order to generate the output? That is wrong too. Then you must have both input and output นะครับ for a process นะครับ it might be in different content or form or both. That means suppose you have one incoming data flow to a process. For example, it's called invoice นะครับ when it becomes the input of the process and you say that okay, this process will generate the output นะครับ it's the same invoice, but what is the difference? I'm sure that when you have the information system, the process shouldn't be just like bring this document and send to another person นะครับ you must do something else as well in that process. For example, if you say that okay, the officer just check this invoice before he sent to another person, so for sure the what to say, the data flow that sent out must be called as checked invoice นะครับ something like that. So okay, you see when we just like try to draw that kind of thing, you see the changing of the state of that document นะครับ or the data flow. Process contain the business logic, also called as business rules นะครับ you may just like write some phrases to explain นะครับ the process a bit. For example, check for the courses นะครับ check for courses, check for availability, validate data, or just like receive order, something like that. These are the process that we should have. So when we have the what to say, when we have the process นะครับ the things that you need to explain inside a process, normally the process usually start with the verb นะครับ with the verb to explain นะครับ that process a bit. Okay, that's why we say that contain business logic, also called business rules. Then we start with the verb first. But anyway นะครับ process is a black box. You don't tell the pseudocode, you don't have any algorithm inside นะครับ just tell what is this process doing. So on the last time นะครับ I showed you for the process and the data flow diagram like this นะครับ okay, let's see the data flow diagram, sorry, the data flow symbol first. Data flow represent one or more data items. It might be a document นะครับ for example, invoice, receipt, registration form, bank notes, bank accounts, payment, something like that. Normally data flows are now นะครับ okay, for example, sorry, in here it said that data flow represent one or more data items and the symbol for data flow is aligned with a single or double arrowhead นะครับ my suggestion is that in order not to make yourself confused, the arrow นะครับ if you would like to say that okay, this data flow run to this process in and out, you should separate them into like two arrows instead นะครับ okay, we'll talk about it later on. Now I would like to explain นะครับ the data flow นะครับ with the process when you just like use them together. In this one, you can see that, okay, for the first one, service performed is sent to this process, and it goes out as invoice, because this process create the invoice from this input, so anything that has been performed by our company will be created as invoice to charge the customer, so this process has one input, one output. This is okay, this is not wrong, you have to know that in this one, when you just like see the data flow like this, in this example, I show the what to say syntactical error only. That one, you can see that this one is said correct, means that syntactically correct, but I mean like logically it depends on your requirements, it doesn't depend on the syntax. So that means sometimes when somebody draw a diagram, the syntax might be correct, logically correct, but I mean in terms of the logic of the diagram, okay, it might be wrong. Then you have to read and understand that data flow diagrams. So what about the second one? Second example is about a process called grade student work. You can see that it starts with the verb grade, right? Okay, grade the student work. So one input that is sent to this process is submitted work, and it generates two output. So the submitted work, for example, let's think if I just like give you a paper, a worksheet to do, and then you just like write down the answer and then submit it to me. I call it as submitted work. And then I mark the score. I return that worksheet to you. That is graded work. I call it as graded work. And also the score will be sent as a student grade. I might just like send to a student, or I might send a student grade to be stored in the data store or into the database as well. This is the one input and two output. This is okay. You have one input, you have two output, no problem. You may have 10 input and one output. That is okay too. You may have one input, 5 outputs. That are okay too. But if you ask me that, Ajahn, what about the syntax? Is it correct? Yes, it's correct. But how about the logic? I don't know. You have to just like see from the requirements of the users that you gather whether they mean the same thing as you're trying to draw and represent in the data flow diagram or not. Next one, 2 input, 1 output. You can see that in this one, the process is called calculate gross pay. Start with verb as well. While 2 inputs, they are nouns. Hours work mean number of hours work that you send into this gross pay, and the pay rate of that employee is sent into the gross pay as well. When we calculate gross pay, the output for this calculation is gross pay. It might be sent to store in a data store, or it might be sent to tell or to inform the employee. Depends. This one, it just don't tell you, it just like tell you just to see the input and output. 2 input, 1 output. Yes, this is possible. Lastly, we show the continuation of the process and the data flow. 1 input to verify order. The order is sent to verify order process. Verify order process generate 1 output that is accepted order. You can see that actually they are the same now. Order and order. But the things that is different is that they change the status to be accepted order. So you can see that this is a trick in order to write down the data flow. If you know that actually they are the same document, the things that you have to do is that define the difference before entering this process. And after exiting from this process, what is the difference? You can see that this order, to verify the order, somebody may say that, can I use the word verified order? Yes, you can. Normally, for the data flow, we may use the adjective นะครับ to help in order to magnify the meaning นะครับ or status of that data flow นะครับ and then the accepted order นะครับ is sent to a process called assemble order นะครับ they do something inside and finally it caused the inventory change. Some of you may say that อาจารย์ and where is the accepted orders gone? I don't know, maybe they keep somewhere inside that process. Depends on your requirements that you gather นะครับ sometimes the inventory change might be a document that they also attach the accepted order in it as well นะครับ you never know because in this one it just tell that okay there is a coming out data flow that is called as inventory change. In terms of syntax, this one is okay too, no problem. One input, one output becomes another input of another process and generate another output. Perhaps everything seems to be okay for the last example here. After that, we talk about the next slide, slide number 10. In slide number 10, I talk about data store. When we talk about data store, just think about a file, a database that we use to keep the data, a folder that we keep the data. So we use data store symbol to represent data that the system store. It can be in terms of digital form or hard copy forms, no problem. We use the same data store symbol to represent. Physical characteristics of data store are unimportant because you are concerned only with logical model นะครับ so don't worry that I don't know that okay what kind of database that we are going to use, whether it is the hard copy or is this the digital file. You don't worry about this one. You know that you have to keep this data. That's it นะครับ that is a goal for data store that you have to use in data flow diagram. In this one นะครับ let's see. One process นะครับ called post payment send the output called customer payment to be stored in the daily payment data store. While the daily payment นะครับ is used as the input called daily payment นะครับ data flow sent into prepare deposit นะครับ in another process. So in the data store นะครับ normally we have both input and output นะครับ for that data store. But anyway, sometimes you see just one input นะครับ but no output from data store. That is okay. Sometimes you see one output without any input from a data store. That is okay too, because sometimes some of the file is readable นะครับ sorry is the read only file. Then it might be just like you can see that it is just send the input into the process. For example, if we are talking about our ATM card นะครับ our ATM card, oh, sorry not ATM card, talking about like the what to say citizen ID card or what to say MUIC student ID card. That one นะครับ you can see that it is a kind of data store as well. It keeps your personal information over there. Actually when you go to use the student ID card to tap นะครับ on the door access, it doesn't write anything to your card. It's just read only. So that one you can see that your data store send the input to another process. For example, access control นะครับ or door access control or open the door or validate นะครับ the authorization to access the door, something like that. So it just like send the data of that student into the process of authenticate นะครับ of entering the door, something like that. So in this one, let's see the second example นะครับ a process create invoice create นะครับ the output that is data flow called invoice. This data flow is kept in a data store called account receivable นะครับ and for account receivable it might like store many things นะครับ Invoice might be like one of the inputs that it has. And in here, you can see that it has invoice details sent to the post payment process. While post payment send the output payment detail to be kept into account receivable data store. While the last example this one is okay two of them the syntactically they are okay. The last one, process call admit patient send the output admission form to be stored in the patient's data store. Then the diagnosed patient use the symptom data flow that we kept in the patient's data store as its input, and the treat patient process send the treatment to be stored in the patient's data store as well. So in this one, you can see that syntactically, the last example for data store is okay too. Hang on, one output, two input. The second one, we have one output, two input as well. And the first one, we have one input and one output for these data store. They are okay. But on the last class, I finished at this slide. I told you that, okay, for the last symbol, we call it as entity. Entity is the name of, entity might be just like a person, a department, another system. We said that when we have to draw an entity, the name of the entity appears inside the square symbol. It can be terminator. Terminator when means that, okay, the point that we stop everything at the entity. For example, we may say that, okay, the bank, when we talk about like the payment from the students for the tuition fee, the bank receive the money, the payment and the document. They can be the terminator, receive all the things that has been sent from the system, or it might be the source. The source means that it is the point that provide the information into the system, or the sink means that it's the point to receive the information from the system. So when we draw entity, try to think about the person, not the name of a person. Person here might mean like the position of that person, for example, clerk, for example, lecturer, student, staff, OAA staff, something like that. But don't use the name of a person like Paramin, Justin, Nawat as the name of the entity. Because normally we would like to use the data flow diagram to represent the system, not to serve one person only. It must be the common name. But the department name, for example, finance department, warehouse, OAA, science division, computer science program, something like that. That's okay to represent an entity. It depends on your requirement that you gather as well. So last time we finished at this point for the data flow diagram symbol, the symbol that we use. Now, how do we gonna create them? When we have to create a set of data flow diagrams, the things that you have to do is that, okay, we have when we just like consider of creating set of data flow diagrams, you are creating a graphical model of information system based on your fact-finding results or based on requirements of the users. So first, you will review a set of guidelines for drawing data flow diagrams. Then you will learn how to apply these guidelines and create a set of data flow diagrams using a three-step process. The guidelines, firstly, we have to draw a diagram that is called context diagram. The context diagram นะครับ it you have to fit it on one page นะครับ you have to fit it on one page. You can see that for the symbols of data flow diagrams that I showed you before, there is no connectors to connect to other pages. So you have to fit everything on one page. So if you say that, okay, what if we have, let's say, 50 process in our system, what should we do? The things that you have to do is that you have to revise นะครับ your data flow diagrams, and you have to use technique that is what we call partition your data flow diagrams that I'll talk about later, in order to just like complete every related things together in one page only นะครับ and then use the name of the information system as the process name in context diagram, and then use unique names with each set of symbol นะครับ Justin said that how big is one page? I can tell you that A4 ครับ but I mean like actually some people they draw it in A3 and then they just like move around, but if it is in A4 it is easier like for everyone. I mean it's easy to fit in a PDF file, right? If you send a PDF file in the A4 page, that is okay. But if you said no, it's impossible, it's too small, you may draw it in A3 and then squeeze it in นะครับ no problem. But when you learn more, you know that okay, in one A4 page it can fit everything, okay, because unrelated นะครับ or unparallel process can be put in the lower level. So when we talk about context diagram นะครับ let me just like show you how context diagram look like. Let me just have a look on the slide first. Yeah, okay. Yeah, I'll talk about context diagram next on the example is on the next page. Okay, after we just like finish the context diagram already นะครับ the next thing that you have to know is that okay, when you draw the data flow or the arrow, do not cross the line นะครับ this is important นะครับ somebody draw the arrow like this ครับ sorry, like this. Don't do that นะครับ this one you are crossing the line. What should we do? If you say that okay, you need to just like do like this. For example, if you would like to draw นะครับ a line that you need to just like go to another part, for example, okay, you can see that in here it might make you just like cross the line to be like this, right? And I say that no, don't do that. So how to fix this? You may move this entity down so that you don't cross the line, or you may say that okay, you just do like this instead, but don't cross the line, because otherwise it will be difficult to read and understand, because in the real information system you may have hundreds of data flow, and if you cross the line, sometimes you may not know that okay, actually is the line come from this direction or not. The other one might be this one. That's why we never cross the line, because it will make anyone who read these data flow diagrams to be confused. Okay, so apart from this one, provide a unique name and reference number for each process. You can see that I write number 1 on my process like this. So that means every time when you see a process symbol, say it process number 1. They must be the same process. But sometimes if you say that I cannot draw like this because otherwise it will cross the line, you may write the process number 1 again on another point. But when other people see that it's process number 1, they understand that they are the same process. But you may have some limitation in order to draw it, the data flow, otherwise it will cross the line. So that means if you have process number 1 twice in your data flow diagram, they mean the same process. That means the content inside, the process name on both symbols must be the same because they are the same process. But if you say that you have process 1 twice, but process 1 in one box, you say that, okay, validate student number, while another process 1, you say check the grade. This is absolutely wrong. You must use different numbers, maybe number 1 or number 2, something like that. Okay. The next one, obtain as much user input and feedback as possible. That means when you draw the data flow diagrams already, pass it to your users, whether this one that you are drawing makes your users understandable or not. And for you understand, for users understanding and for your intention in order to draw the data flow diagram like that, do both of you mean the same thing or not? Because if they misunderstand, you can explain to them that, okay, this data flow means like this. But when they just like try to understand you and they say that no, this one you are drawing the wrong one, you have to just like use the data flow to point to this process instead, so you can fix that problem immediately. So that's why try to obtain as much user input and feedback as possible. Okay, next one, let me show you the first diagram that you have to draw. If you remember, I talk about context diagram. I talk about context diagram. Let's see the context diagram that we have to do first. How context diagram look like. This is what we call context diagram. You can see that with these symbols, it can fit in one A4 page for sure, right? Make sure the first one, the most important part for anything that is called as context diagram on last batch students, that when they draw a context diagram, some of the students did wrongly. When we call it as a context diagram, there must be only one process in this page. Listen to me carefully. When it's called as context diagram, there must be only one process on this page. The process number must be process number 0 only. The name of the process must be the name of the system. For example, in here, this page is showing context diagram of grading system. For example, if you say that you would like to develop the Sky++, let's say, the context diagram of yours must be one process, number 0, called Sky++ system. Just that. We begin with this one first. It's the center of the page. Draw a process symbol, write number 0, and write the system name. After that, we draw external entity. That means in the data flow diagrams, if you have three entities that are related to these systems, that are student, instructor, and student record system, you draw those three entities first. You can see that student and instructors, they are the name of the, position of the users or entities that are related to this system. While student record system, that is another systemนะครับ that links to grading system here. When you draw the context diagram already, when you draw the external entity already, now you just draw the data flow that links between the system and the entities. For example, in here, you have for students, you have one input that is submitted work to grading system, and one output from grading system to graded work back to the external entity called student. For instructor, one input to the system and one output from the system to instructor. The input to the system is the grading parameters, while the output from the system that is sent to instructor is grade report. While the student record system another system that is related to grading system. One input from student record system to grading system is class roster. And finally, the grading system will create an output called final grade sent to student record system. How do you know which data flow has to be related to which external entity? Is from your information gathering or the requirements or the facts that your users told you. In this one, let's see the explanation a bit. What to say? The yellow box tell you that, okay, it shows you unique reference number for each process. In the context diagram, I told you already that you must have process number 0 only. And process 0 represents the entire grading system. I can tell you that context diagram work as table of content of a book. But this is the table of content of the whole information system. It tells us entities, it tells us data flows that are sending and receiving from each entity and the system. And then it tells the system name, just that. You may have the question that for the previous slides that I showed you before. Okay, let me just show you this slide first. If you remember, in this example, we have many process. We have data store. How come the example that I show you in data in the context diagram doesn't have data store, doesn't have and doesn't have more than one process? I can tell you that because this diagram is context diagram and it works as the table of content only. So that's why it doesn't enter, you don't have everything in this page. For explanation of the system, you go to another level. The next level of the data flow diagram, we call it as diagram 0. So we begin with context diagram first, and then we follow by diagram 0. Diagram 0 look like this. The right hand side, diagram 0 is on the right hand side in here. Oh, sorry. This one. Left hand side is a context diagram. Okay, now let me explain to you. For the diagram 0, in this one, it consists of 4 processes. 4 processes. It consists of 3 external entities. Okay, let's see. Let me explain to you for the diagram 0. We say that, okay, how to read. For diagram 0, we start the process with process number 1. So the way that you have to understand the diagram 0 is that you start from process 1 first and see what are input for this process number 1 from what components. You can see that in process 1 establish gradebook you need the input นะครับ that are class roster นะครับ from student record system and you need the input นะครับ that is grading parameters from instructor นะครับ these data will be sent into established gradebook and established gradebook process will generate the output that is called class gradebook. Class gradebook will be stored in data store D1 that is what we call gradebook นะครับ that is the end of process number 1 after that the next thing to read is the process number 2 นะครับ process number 2 has the input นะครับ has one input and one output the input นะครับ from process number 2 นะครับ is grading detail grading detail we get it from gradebook sent to assign final grade นะครับ the final grade will be sent to student record system นะครับ as the output นะครับ that is process number 2 now let's move on to process 3 process 3 is the grade student work นะครับ grade student work has one input and 2 output student entity will send the submitted work to grade student work process the grade student work process นะครับ will generate 2 things as the output the first one student grade will be sent นะครับ to be stored in the data store D1 gradebook and the graded work will be returned to students นะครับ here so that is all for process 3 นะครับ and lastly the last process for process number 4 produce grade report this process has one input and one output the input is class detail นะครับ that this process obtained from gradebook นะครับ D1 gradebook data store and it generate grade report sent back to the instructor นะครับ send back to the instructor นะครับ okay and that is all for the what to say the part of the process number 4 นะครับ let me just like show you something a bit before I explain more you can see that when you draw the data flow นะครับ like this line try to split the line นะครับ you can see that this one it makes us confused because firstly you don't know that this line is like this or not นะครับ if the line is like this line is wrong because an entity cannot send anything to data store when the entity would like to send anything to be stored in a data store it has to pass a process first นะครับ but if you draw like this line นะครับ or this data flow represents that this entity is sending final grade to gradebook that is wrong นะครับ what happened to this let me show the correct one นะครับ how is the correct line the correct line is like this ครับ both lines called final grade come out from assigned final grade process นะครับ but when you draw the line like the black line that they draw นะครับ in here it is difficult to read นะครับ and sometimes we guess นะครับ the origin and the destination wrongly that's why you should just like try to split the arrows นะครับ as much as you can นะครับ okay right okay so in this one นะครับ this is the way to understand the data flow diagram นะครับ Now what asks me that, so is diagram 0 is more detailed version of context diagram? Yes,ครับ. It is detailed diagram because context diagram is table of content only นะครับ and when it's named as diagram 0 you can have diagram 1 diagram 2 meaning are the same ครับ diagram 1 is a detailed version of diagram 0 diagram 2 is the detailed version of diagram 1. That's why I told you that when you partition them into detailed data flow, you don't need to write a lot of process inside one page. So in one page, you can see that in here, you see diagram 0, you have just 4 process. But if you go to diagram 1, you can have diagram 1 of process 1 that consists of another 5 or 6 more processes as well นะครับ Karan has a question that can there be a storage symbol in context diagram? No ครับ context diagram consists of one process นะครับ and many entities and data flow, just that. And not every data flow appear in diagram 0. We have just some data flow only. Let me show you what do I mean in this one. Okay. Firstly, นะครับ from diagram 0, if you want to turn it to context diagram นะครับ there are 2 techniques นะครับ some people start from context diagram first and then derive them to be diagram 0. But for me นะครับ I start from diagram 0 first and compile them as the context diagram นะครับ you can do both way นะครับ either direction that you can do. Now let me show you นะครับ how can I just like turn the context diagram to be diagram 0. Firstly, I see the external entity first. There are 3 of them. See that? So that means I draw the diagram 0 นะครับ I draw process number 0 first and then I draw 3 entities: student record, system, and instructor. Just that first. Okay. Now I have entities, I have a process, and then I write the name of the process, that is this grading system นะครับ After that, what are the data flow นะครับ that will be linked นะครับ like this. So okay, let me change the color of the pen. Just have a look up. Now let's talk about student record system first. It has 1 input, 1 output, right? So that means in your context diagram, it must have 1 input, 1 output as well. 1 input is final grade here. 1 output is class roster here. Now we finish at the we finish with the student record system already. Now talk about instructor. Instructor has 1 input and 1 output. The input is grade report. Output is grading parameter. You draw input นะครับ from system to instructor. This one is grade report. You see that? And output grading parameter. Here is the output. Okay. Lastly, student entity. The input to student entity is graded work. There's 1 input and 1 output is submitted work. That means in context diagram, you must have 1 input, 1 output for student as well. The input that is graded work is here. and the output that is submitted work นะครับ is there. That's all. This is context diagram. You can see that นะครับ you can see that some of data flow like class grade book, class detail, final grade, grading detail, student grade doesn't appear in the diagram 0 at all. Sorry, doesn't appear in the context diagram at all because it's inside this system นะครับ while the green lines represent the input and output to the external entity that might be a person or another system. That's why it must be outstandingly written in the context diagram. This is the way in order to turn your to turn your diagram 0 to be context diagram. But for some people, they start from context diagram first because it is the overview picture of the system. They may say that, okay, if they ask, for example, in this system, if you ask the OAA people, OAA staff, and you say that, okay, OAA staff might tell you that, okay, we use another system to keep the information, and send the information to Sky Plus, students are related to this system, instructor are related to this system. And they say that, okay, for the old system, we generate class roster to the Sky Plus, and the Sky Plus finally send the final grade back to be stored in the Sky system, let's say. So then you just like start drawing the green line for the data flow until you finish. And after that, you just like break down into details when you go to the diagram 0. So this one, it depends on you. You can just like start from context diagram first or start from diagram 0 first and summarize them as a context diagram. Up to you. But I mean, like I will tell you that in my exam, I will ask you to draw both context diagram and diagram 0. If you are not fluent in drawing everything from the overview, you draw you draw diagram 0 first, and then just like summarize them, compile them as the context diagram as I showed you before, something like that. Bear in mind, no data store, in the context diagram. Context diagram has only one process, and the number must be process number 0, and it's the name of the system as the name of the process. Just that. Okay, right. For this example, do you have any questions, Kap? All right. If you don't have any question about this example, now let's move on to the next slide. On the next slide, you have to just like know that if there are some data flows in both directions, even though in some of the books tell you that you can use double-headed arrow, but from my suggestion, if you remember this example, you can see that it makes this one to be confusing. This one. My suggestion is that if you just like separate them into 2 different lines, it's better. Next, next, we talk about the next instruction. Diagram 0 is an exploded view of process 0. Process 0 means the system, the whole system. Okay. Parent diagram and child diagram. Parent diagram and child diagram. You can see that in this example, diagrams. The context diagram is the parent diagram of diagram 0. If you have more detail, for example, grade student work, if you say that grade student work process has a detail, you can explode grade student work into process 3.1, 3.2, 3.3, 3.4, and so on. Similar way as you did with when you explode context diagram to diagram 0 นะครับ for example if you say that okay for grade student work นะครับ we say that firstly we check plagiarism second one นะครับ compare the result with a key นะครับ third sub process is to mark the score or write the score on the paper นะครับ something like that you can see that if I say that okay first one is plagiarism checking you can see that plagiarism checking when you compare with assigned final grade produce grade report or established grade book they are not related and they are in different levels so you might say that hey I think that okay the level นะครับ of checking plagiarism should be under grade student work then you should have the Char diagram of process 3 นะครับ you may have 3.1 นะครับ check for plagiarism and output from check plagiarism is just like to send that work นะครับ in order to compare with a key something like that and so on and when you just like break it into the Char diagram you might see that oh the result of plagiarism checking must be sent to student as well then you can also update นะครับ the process output นะครับ of process 3 to student like plagiarism report something like that as well นะครับ okay so that means when you just like draw the diagram you get the input and output and feedback as well back and forth นะครับ so that you can just like draw it and then explain to your users as well นะครับ when you get this one already นะครับ the next one we say that functional primitives normally whenever you draw the data flow diagrams นะครับ we try to just like make each process to explain the functionality นะครับ of the task or the process that you have done นะครับ and bear in mind when we talk about a process might be larger than one function so it might consist of some functions inside for example validate score validate plagiarism compare the work something like that that might be just like the I mean like detail function underneath each process that you may have นะครับ but you can see that when I explain you about the process like this I never tell you that how to check plagiarism how to compare the work with the key something like that I just tell you that there is a comparison between the key with the work of the student there is the plagiarism checking just that นะครับ okay after that นะครับ when we talk about diagram 0 นะครับ sometimes we have lower level diagram I can tell you that not every diagram has lower level diagram นะครับ some of the diagram might be finished at diagram 0 some of the process might be finished at diagram 1 for example if we say that okay there is a process called make payment let's say make payment is make payment you just go to the bank and pay the money just that let's say you don't have any detail more than that that means that process make payment doesn't have lower level diagram suppose we say that make payment is process number 5 you don't have 5.1 5.2 5.3 because make payment is make payment just that นะครับ so that means you don't need to worry too much every process sometimes somebody say that I don't want to draw or I don't want to draw many process because I'm afraid that I have to create the lower level diagram of those processes นะครับ no need ครับ some process doesn't have the sub process you don't need to just like break down into like lower level diagrams นะครับ okay let's see the explanation for this one first draw the lower level diagram here you must use leveling and balancing techniques how can we do that normally we use from experience ครับ when you read the process name and if you see that they shouldn't be on diagram 0 then you push it down into diagram 1 for example if you say that okay compare the work with the key, with the answer key. You can see that that one, it's too detailed. If you put in the diagram 0, then you just like level it down into like lower level. And balancing techniques means that, okay, you just like when you draw, if you know that, okay, there are just like 5 processes, 3 processes are related to customer, 1 process is related to warehouse, the other process is related to another entity, something like that. How do you gonna draw the whole page, not to be just like too heavy on 1 process? You just like scatter them into just like different part of the page, something like that. For the leveling examples, we use a series of increasingly detailed DFD to describe an information system. So we may use the technique that is what we call exploding, partitioning, or decomposing. Depends on whether our process need to be exploded into details or not, or partition into like detailed process or not. For example, in this one, you can see that the customer send the order to process 1.1 to verify order. Also, in order to verify order, the product detail will be sent to verify order process. Credit status from customer data store is sent to verify order as well. So this process 1.1 has 3 input, and it generates 2 output. One output is accepted order. The other one is rejected order. Let's see 1.2 first. Rejected order will be sent into process 1.2 to prepare reject notice. The reject notice will be prepared and then sent to the customer. We call order reject notice is sent to the customer, and credit history is sent to be kept at the customer's data store. In this one, for accepted order will be sent to process 1.3. Process 1.3 assemble order will have to use 2 input. One is accepted order from process 1.1. The other input is picking detail we get from products table, product data store. And when we assemble order, it generates 2 output. One output is picking list will be sent to the warehouse entity, and inventory change information will be sent to product data store to be kept. So this one, you can see that we may say that, okay, for this diagram, it might be a process that is called order processing, something like that, or process order. But if we say that, okay, for process order, users might not see the clearer picture, then we break it down into like these sub processes: verify order, prepare reject notice, and assemble order, so that they know what does process order means. Something like that. Something that I would like you to notice in this diagram, you can see that we have 1.1, 1.2, 1.3. So you can imply that this is the exploding level of process number 1 for sure. Another thing that I want you to see is that every single data flow must have the name. You have to write the name of each data flow. Like this as well. Next, the data store must have the number as well. You can see that when I just like draw the symbol data store, we didn't show the number, but actually you need to have the data store number as well. In this example, it's D2 and D3, because finally we will use this kind of the data store to create the database later on, and you need to have a description for data store that can be referred to as D2, D3, something like that as its short name. Okay. After that นะครับ when you know how to just like draw the lower level diagrams or partition them already, the next thing that you have to know is that, okay, how do we gonna balance your diagram? You can see that in here นะครับ for the balancing it said that you have to ensure that input and output data flows นะครับ of parents are maintained on the child DFD. The example in here you can see that when you draw this one นะครับ it tries to balance the diagram นะครับ you can see that the external entity just like put in each corner, and for the process we have 3 process, we just put them in the middle นะครับ the data store นะครับ to data store we balance them นะครับ like a mirror นะครับ for this diagram. So this one will be easy when you just like look at it or when you try to just like edit it later on นะครับ okay, right, so this is the basic ideas for data flow diagrams นะครับ up to this point do you have any questions ครับ anyone? We have to practice นะครับ in this one I'll set it up in the workshop because in the class I'll just like explain like all the things that you should know first นะครับ and then we just like have to discuss and brainstorm when we do in the workshop. Okay, right, okay, any questions or comments for the DFD? All right, if there's no question นะครับ let me move on to the next two that we have to use for modeling the information นะครับ that you gather from the users. The next tool that we have to use is what we call data dictionary นะครับ a data dictionary or we may call it as data repository นะครับ this kind of tool is a central storehouse of information about systems data นะครับ. An analyst uses data dictionary to collect, document, and organize specific facts about the system. Also, we use it to define and describe all data elements and meaningful combinations of data elements in the data dictionary as well. Data dictionary works similarly to a language dictionary. It has a word, and then its explanation. For the data dictionary is similar. You have the term that you would like to describe นะครับ might be the name of a document, might be the name of the data flow, and after that you just describe what are the fields that we have in there, what are the properties like, okay, what data type that you have to use นะครับ what is the size of the data that has been transferred if you have to use this data dictionary, something like that. For example, if you said that, okay, the maximum length for the students grade นะครับ must be not more than like 1 kilobyte, something like that, and then you just like explain นะครับ what are the components, student ID นะครับ and then the repetitive group of like the course ID, course name, and the score, something like that, and the grade as well. Okay, so in this one when we talk about data dictionary นะครับ inside it has a data element นะครับ a data element also called as data item or field นะครับ or sometimes it is a variable. This is the smallest piece of data that has a meaning in each data dictionary นะครับ let me give you an example. Student ID นะครับ that is data item or a field. Student name นะครับ student birth date, something like that. These are the data elements. Okay, data elements are combined into records, also called data structure. So that's why นะครับ when you have to when you come to study for my course, okay, you have to study for data structure course before, because it will help you to understand more in order to just like collect the data into the data dictionary properly. A record is a meaningful combination of related data elements that is included in a data flow or retained in a data store. So that means when you have to prepare data dictionary, normally data dictionary must be defined for each data flow, and must be defined for the data store that you collect the data or information in your data flow diagram as well. So what should we do? How do we gonna record the data dictionary? Somebody said that should we use like Microsoft Word to help? Somebody, if they are just like the user side, for example, if you have key users to work with your team and they don't have the ideas how they're gonna do it, they may use Excel or they may use Word to record the data dictionary. My suggestion, if you have to work with non-technical key users, the things that you should help them is that you should you should train them for how to use some software to help recording this data dictionary. The tools that we use is case tools, computer aided software engineering tools. We use this tool to help doing documentation for data dictionary. So when you have the more complex, we said that the more complex the system, the more difficult is to maintain full and accurate documentation, because you cannot type every single data flows, data dictionary on Microsoft Word. But if you have the, if you use the case tool, once you draw a data flow, it asks you immediately that, okay, how do you gonna define the data dictionary for this data flow? Then you better use the case tool to help. Modern case tool help simplifying the task. A case repository ensures data consistency. So because like if you create a new data flow, but it's repeating to the old one, it just like pop up to ask you that, do you mean the same data flow that you created data dictionary before or not? Here I have a question from Tasapon. What is different between lower level DFD and Char DFD? The same lower level DFD and Char DFD means the same thing. Sometimes you might see diagram 1, that is the Char DFD, and that is the lower level diagram of diagram 0. Same thing. Okay. If you have any question, you feel free to just like type the question in the chat box. Okay. Now you will learn more about case tools in the next part. I'll just like show you some example to use like this kind of case tool as well. To understand the case tool. In here, this is the example of data elements. How do you gonna document them? The data element, every data element, every field, of your data in the information system must be documented in the data dictionary. Why is that? The system analysts collect the information, collect the requirement from users. You get the example of the documents of the legacy system, or the old system, and then you may have to design the new system or new documents for the users as well. Each field, normally it is generated from the new system, or it might be entered into the system. If you don't record them, or if you don't document them properly in the data dictionary, how can developers develop the software to accept those values, or to generate those values, or to retrieve those values to the users? That's why you have to document them. Document every data element in data dictionary. Objective is the same, to provide clear, comprehensive information about data and process that make up the system. For example, in here, system, payroll system, date, which data you record this data element, label, what is the name of that data element, called social security number, alias or nickname, it might be called as SSN, type and length 9N, that is 9-digit number, default value none, source employee application form, where can you find this data element in employee application form, acceptable value any positive numbers, or you may say that any positive integer, something like that. Security นะครับ this is payroll department, so these numbers นะครับ it means that these numbers must be kept and retrieved by social security number sorry, can be retrieved by payroll department only นะครับ you can write some more description if you want to. User responsibility, who is responsible for this data element นะครับ and if you have description and comments, you can write it down in here. You can add some more boxes to explain about this data element as well นะครับ or you may use like the case tool to help generating this kind of data element document as well in here. But you can see that this is just like the data element that they have. You need to have the description in there นะครับ after that นะครับ the following attributes usually are recorded and described for each data element. The first one, the name and the label of that data element, alias, because some of the people or some other system use different name. That's why you have to provide the alias. For example, student ID. Some of the system may be called as student NO. Some system call this data element as student number. Some of the system call this value as student ID, something like that. So that's why you need to have the alias, so that when นะครับ the data has been sent from another system นะครับ to this system or sent out from this system to another system, the name of the data element might be changed. You have to find the compatibility นะครับ next, type and length. This is important because this one it's important in for many purposes. The first one, if we said that okay, we will store it in a database. In the database, you have to set up a variable in order to store the data as well นะครับ you have to prepare the data structure to store this data as well. Then you have to know type and length, right? Apart from that one, it's good for planning for communication. For example, if you say that okay, you need to know the bandwidth that you have to use in order to send the data. For example, shall we send it through you by using 4G? Is it enough or not? Or if we say that okay, you make the data transfer to be very slow, 5G is okay, or you have to use at least the Wi-Fi of the company, something like that. Apart from that one, it's good for preparing or planning for what we call sizing. Sizing means that when you have to prepare the server in order to just like run this system, sizing is important นะครับ it tells us that okay, what kind of CPUs that we have to use, what about the memories, what is the size of the memory to use for processing this data, what I mean like storage, what size of the hard drive do we have to buy it, and when you have to do the backup, how can you do the backup by just like the type and length of the data. Because okay, let me just give you an example ครับ there is one car manufacturing company นะครับ right now they are in Thailand for just like more than 10 years already. In the past, when they came to Thailand at the first time นะครับ before that they had the dealers in Thailand only. They didn't have the manufacturing plants in Thailand. So that means most, I mean, not most, all of the cars were imported. And then that brand would like to set up the manufacturing plant in Thailand นะครับ as well as their branch of the company in Thailand too. So they plan to have a software นะครับ and enterprise software that is called SAP. Right now, SAP is in is just like popular and well known นะครับ as the enterprise software. Even in MU and MUIC, we use that software as well to control all of the resources that we have got. Same as the business ครับ they have like that. What happened was they did the planning, the sizing wrongly so when they start using the server for SAP for around a month, the resources were depleted. Hard drive were full. Memory were full. They couldn't run anything. So the system was freezing. Luckily that there were not many transactions at that time because they still used like their dealers to just like operate the works. So at that time, that car company had to stop using SAP for a month because they couldn't do anything with it. The only way they could do was that they had to replace their server with a new one. Unfortunately, at that time, if you would like to have or if you would like to obtain a new server, most of the brand name servers were imported from Singapore through the ship. It took around one month in order to pass all the customs and shipping to Thailand. That's why they had to stop for a month. During that time, they had to just like use the secondary server from their hardware vendors together with their headquarters server to help. But it couldn't run much because they had to just like, I mean, in the headquarters, they had to just like then run their transactions as well. So that's why during those 1 month, the person who just like prepared the sizing was blamed a lot, because they didn't plan properly. That's why as I told you, you have to just like think about the type and length of each data element and record in the documentation properly. Now we talk about default value. Is that value has a default value or not? For example, if we say that, okay, when we talk about the faculty where students are studying, and this is MUIC system, the default value for the faculty is MUIC, something like that. And for acceptable values is for validation, to check for the validity of the data that is accepted. Taran said that, is this real story? Yes, it's real story, and that company is a big company too. So that's why I cannot tell you the name of the company. Right. Okay. Next, the next thing that we usually record for the attributes in the data elements are source, where you get this data from, security, because if it is the production or the real system, we need to ask for the security as well, because sometimes, for example, if we say that we're talking about citizen ID number, it is secure. The security must be controlled as well. For example, we say that OAA will know the citizen ID number of students. Only some people only. But for instructor like me, if I have to just like see your citizen ID number, I don't know. I don't see it. And if you are my advisee, I don't see your citizen ID number or passport number as well. Even your phone number, I cannot access because they say that, okay, why does the instructor or advisor needs to know? For advisor, it's okay. I might see your phone number, but as the instructor do not see the phone number of the students or address of the student. Responsible users and description and comments. Okay, right. Before I move on to the next part of the data dictionary, do you have any questions about like the data elements? For sizing, problems I'll talk about it next on when we reach the part that we talk about the documentation and we plan for the hardware at that time. Okay, then if you don't have any question for data elements, let me continue with the next slide. The next slide that I'm going to talk about is the data flow นะครับ When you have to record or document the data flow นะครับ these are typical attributes that you should have. First, data flow name or label, description of it, alternate name or what to say alias นะครับ or nickname นะครับ origin, destination means that okay, where is the place that generate this data flow and where is the destination that receive this data flow นะครับ Let me show you for origin and destination นะครับ in here นะครับ data flow like this, like class roster. Origin is student record system, destination is process 1 นะครับ for student grade, origin is process 3, destination is data store D1 นะครับ Okay, this is the example of the origin and destination of the data flow นะครับ Next is record นะครับ What is the record นะครับ that we use to store that data flow? For example, if this data flow is a record in the database, what is that record name นะครับ Volume and frequency นะครับ This one is used for planning of the sizing of your server as well นะครับ for volume and frequency, because we have to know how many records, how dense is the data or data flow that you have to store นะครับ so that we can plan for the the size of the hard drive and the size of the memory properly นะครับ in this one. Okay, right. So นะครับ this is the data flow นะครับ I think I better stop at this point นะครับ